Hello, I'm going to go over this worksheet using Supernova to calculate astronomical distances. And it talks about this idea here, but there's certain types of supernova, type 1a, that scientists have used for a long time to determine distance to a galaxy that supernova is found in. And the concept is fairly straightforward. The idea is that the further away a light source is, the more dim it is, right? So a candle that's up close, you know is up close, is very bright. But when it's far away, 100 feet away, it doesn't appear as bright. And there are some mathematics that go along with this to determine how far away it is if you know how bright it is. Well, these supernova that we find in galaxies, if it's type 1a, they are the same magnitude, or roughly the same magnitude, same brightness, every time they explode. So because we know what that magnitude is, we can use this equation right here. It looks intimidating, but it's not, to figure out how far away that supernova is. All right, let's do some of these. We'll do a couple of examples. So I have this big equation. Again, not as bad as you think. What we're going to be looking for is D. So that's what we want to find out. Little m is the apparent magnitude, which for each problem I'll give you. M equals 13. M equals 15. That's what that little m is. So we'll have that number. Capital M is the absolute magnitude, which is going to be the same every time. So it's always going to be negative 19.5 for each of these problems. So now we know M. We know M, we know little m, big M, and we're just trying to figure out D. So let's do an example. I have M equals 13. Okay, so let's set this up. D equals 10. Now this whole thing is raised to the power of 10. So 10 to the this, right? So I'm going to write this out. My little m is 13. I know that from here, right? Minus big M, which is always going to be negative 19.5. And then I'm going to add 5. This, once I figure that out, is going to be divided by 5. So let's figure this top part out together. You can do this in any way you want, but you'll notice that the negative of negative 19 is actually positive 19.5, right? So this is actually always going to be a positive 19.5. So that means 13 plus 19.5 plus 5 equals 37.5. So that's how much this top part is, 37.5. Now I'm going to divide 37.5 by 5. Divided by 5 equals 7.5. So that means, and I'm rewriting this up here, this is 10 to the 7.5. Now the easiest way to calculate this is using the calculator on your phones, because if you turn it sideways, you can get the scientific calculator. So use your phones, turn it sideways, scientific calculator. If you got to use one of these, that's fine too. 10 to the 7.5, well, I have 7.5 here, and your scientific calculators will have this button, 10x. So for me, I have to shift over to 10x, but when I do that, it does this 10 to the 7.5 automatically. And I'm going to take this number and round it. 3162277, and it's 6.6. We're going to round that up to 7. So the distance to that object is 31 million parsecs, approximately. Very far away. Andromeda Galaxy is 700,000 parsecs away. Let's do another one, and you'll see that it works the same way. Let's do this one, M28. So we're going to set it up again. We're looking for d equals 10 to the what? Well, remember my little m is given at 28. 28 minus 19.5 again. 19.5 is what our capital M is. Plus 5. So 28 plus 19.5 plus 5 equals 52.5. So this whole thing equals 52.5. Now remember, the negative of a negative is a positive. That's why I added 19.5. This whole thing gets divided by 5 right here. So 52.5 divided by 5 equals 10.5. That means I got to figure out 10 to the 10.5. So again, you could use this button up here, that 10x button. I'm going to shift 10x, and that gives me, now you'll notice it's putting it in scientific notation. You can do this if you want. If you're using your calculator on your phone in scientific mode, it'll give you the whole number. It has enough room to give you the whole number. But you can also do it scientific notation. That's fine. We're going to round it to 2 decimals. So this is 3.16 times 10. What do I raise this 10 to? Whatever number they give you here. In this case, it also happens to be 10. 3.16 times 10 to the 10th. And we've done enough with scientific notation that I'm okay with you doing that. All right, let me know if you have any other questions. Thank you very much.